going. Okay, so today I have three big concepts that I want to cover. So before we get to that, let me just remind us of where we're at. So I sent out an email last night, but just to remind you, so the Connect assignment is due Friday this week, so a little different than we've had the last couple weeks, and that's because problem set 2 is also posted. And that's going to be due Sunday night, and that's going to take you into Excel again and have you do some tasks in there, some of the visualization stuff that we've done in chapters 2, 3, and 4. So the process will be the same. It's on Canvas. Download that file. There's a text box in there with some tasks. You can complete those. Some of them have you inserting like a pie chart or something. But other ones you can just kind of write out your answer in the text box, maybe in a different color font to help me out. But or you can insert another text box and write in there. But then save that file and then upload it back to Canvas. Now, if you downloaded the file prior to probably 9:30 or 10:30 this morning, you're going to need to go re-download it because I made a technical mistake, and I saved the file as a .csv file. And that's a comma-separated variable file, and it's a very common data storage file. And in fact, almost any data program can read a comma-separated variable file, and it's really it's just all of the data, whatever our data is all clumped together. Your name is Henry, or maybe this is Henry Ford, I don't know. But all of the data is just separated by commas, and then another one could be George. Okay, and what I want to highlight here, and this is not important for the class, but just this is what a comma-separated variable file is, or a .csv file is, and I saved it like that. And that works for all of the data would have come through. But the specific stuff to Excel, such as the text box, did not come through, right? So what I resaved it as is a .xlsx, I think that's what it is, the most current Excel file. So if you did download it earlier, sometime yesterday or this morning, you'll need to go back on and find it again. This is a more efficient way to store data. It takes up less bytes because you can kind of scrunch everything together. So that's why you see it that way, but it does lose a little bit of the specificity of the file that you save it in. So, So thanks. A couple of people brought that to my attention, which is good. It means you're already pulling it up and trying to work on it, so that's good. Okay. I also mentioned in my email yesterday about office hours, and it kind of dawned on me that a number of you, especially freshmen, may not be as familiar with the concept of office hours. And so I wanted to kind of outline a little bit more about what that is and kind of let you know that time is there for you if you need it. And it's, obviously I want to be available for you at when you need me, but it's hard to schedule and find times when I'm available and you're available. So this is a dedicated time where you can know that I should be available, and so feel free to jump on in. And in a normal context, I would just be in my office with the door open. Anybody can come on in. So the same thing will be true on Zoom. Feel free to jump in there. There might be 3 other students in there as well, and we'll kind of have a roundtable discussion or answer questions as we get to them. And just lastly, if I'm not in there in that virtual room, usually I get a little message, but also feel free to email me and just be like, I came to office hours and I'm just letting you know I'm here. and then I will for sure, one of those methods will get to me, and I'll make sure to jump on. So, yeah. So again, that's Wednesdays and Fridays from 1:30 to 3:30, 1:30 to 2:30. And if those times don't work for you, please email me and we can find another time to meet. All right. So to the tasks of today, I want to get through 3 concepts. So the first one being percentiles, okay, and that's a broad concept that covers quartiles and deciles and all this other stuff that we'll get to. And then I want to turn and look at box plots. And then lastly, talk about contingency tables, or pivot tables as they're called in Excel. And so these are 3 pretty useful concepts. They also take a little time to kind of sink into your brain, and that's why I want to spend the time today focusing on that. There's other things in Chapter 4, but I think reading the text and watching the videos online, you'll be able to grasp. We've seen scatter plots. You've all seen scatter plots, and so it shouldn't take too long for that to sink in. But these 3 concepts, I think, will be helpful to see. So the way we're going to do that is I'm going to write out some data that we'll play around with today, and I'm going to figure out where I am. I can go way over here. Okay, so I'm going to write out 19 observations, and I'm going to order them. So much like when we did the median, we wanted the data sorted from smallest to largest. I'm going to kind of already have done that, and so I'm also going to make a column that's just listed 1 to 19, so I can reference where I'm at. So the variable I'm interested in is not this 1, 2, 3, 4, 5, 6, all the way to 19. This is just the observation number. And oftentimes when I'm working with the data set, I'll just make, if it doesn't have a column like this, I'll often make one just so I can keep my head straight. But what I want is, I'm going to focus in on this variable, and I'm going to consider it distance to work. Okay, so that maybe this is the commute distance to work back when people didn't just work from home. And the following values. So 3, 4, 6, 6, 7, 7. Try to keep this kind of even. 8, 10, 10, 12, 13, 14, 14, 14, 15, 16, 22, 30, and 37. Okay, so I have 19 observations here, and I have the distance each of these travel to work. And so we're going to talk about percentiles, but first I want to just talk about something we've already covered last chapter, and that is median. Right? And so one way to summarize the center of our data is the median. And how do we find the median? Well, we look at the ordered data and we pick the value in the middle. Right? And so helping us out here, we have 19 values, so we want the 10th value, because I know 9 of them will be smaller and 9 will be larger. Right? And so the median is that middle value. So the median is 12. Okay, and then just to rehash, if I had 20 values here, I wouldn't have an exact middle. I would need to take the middle of 10 and 11. Remember, so because there's no exact value in the middle, we just take the middle, and that would be, 12 and a half. Okay, but in our case, we have a nice odd number, and so we can pick that exact value of 12. Okay, so the way I mentioned it was, it's one way to talk about the middle of our value. It also, we can think of it as half of the values are smaller, half of the values are larger, right? So compared to 12, half of them are smaller, half are larger. Another way to think about that is 50% are smaller and 50% are larger, right? So 50% And so we can think of this as 50% of values are smaller. Right? And so what that is the 50th percentile. So this is all different ways to talk about the median, the center of our data, in terms of the order. So the 50th percentile is the median. But we could use that same concept for any percentile, right? We wouldn't have to just say the 50th. We could say something like, where's the 40th percentile? Okay, and we'll go ahead and calculate that type of thing today. And a more commonly used one is, where's the 25th percentile? And along with that, we could think about the 75th percentile. Now, we often won't even refer to this as the 25th percentile. Instead, what are we doing here? We're breaking it into fourths. We're breaking it into quarters. So we will refer to this as the first quartile and the third quartile. Right? And similarly, the second quartile. Okay, there's a lot of terms that we can fit with the 50th percentile. It fits nicely. So, but obviously, right? So 2/4 of the way through the basketball game, you're halfway through. So, where you're right in the middle. So the first, second, and third quartiles are used quite a bit as a way to kind of chunk up our data, right? So the median chunks it in half, and this chunks it into 4 parts. Okay, so how do we find those values? We could logic our way through much like we did with the median, right? The median, run it half above, half below. In some sense, the first quartile is the median of the first half. And the third quartile is the median of the second half. So we could logic our way through it, but an easier way, or a more universally useful way, is to use a formula, LP, which stands for location of the percentile, so LP is equal to n plus 1, and then p over 100. So the first few times we use this, it's going to feel a little like overkill, because again, we could probably logic our way through, but this is going to be a very flexible equation where we can put in any percentile, and so it turns out to be pretty helpful. So we have two variables here. N, again, anytime we see this in statistics, it's the number of observations. So here we have 19. Okay, so we simply put n, we add 1, and we'll see as we do this, that helps us end up on the exact right value we want. But so n plus 1, and then p is simply that percent that we're looking for. Okay, so for the first quartile, we actually plug in 25. We plug in 25th percent, and we're just dividing by 100 to bring it into percents. So for the first quartile, this is L25, and I'm just writing the 25 here to indicate I'm looking for that 25th percentile. 19 plus 1, and then 25 over 100. So this becomes 20, and then 1/4, okay? Or you could multiply it out. This is 20 times 25 is 500, and then divided by 100. So either way, you're going to get 5. Okay, so 5. Now 5 is not the answer to what the first quartile is. 5 is the location of the percentile. So I want to make special note of that, because people sometimes forget this last step. All we're doing here is finding the location of the value. We have to then go to our ordered data and look up the 5th observation. And that value is the first quartile. So our first quartile is, let me pick a different color, 7. Okay, so let's just walk through it again with, so L50 is going to be 19 plus 1, 50 over 100, right? It's going to be half of 20, so 10. That's going to be the exact same thing we did with median. So if you want to only learn this method, you can forget about how we did median before, because this will give you the median, right? The 10th observation, 12. Same thing we had. Okay, and then lastly, L75, 19 plus 1, 75 over 100 is going to be 15. Again, I know we could have logicked our way to this, but as we'll see, it's more flexible. Whoop, where am I at? Third quartile is 15. Now, this ended up being true that the 15th observation was 15, but remember, in general, we need to go look up the 15th ranked observation and find the value of that. Now, technically, there's a fourth quartile, right? And we could calculate this out. It'll actually give us 20, which we don't have. But really, the fourth quartile is just our largest value. You're never going to see that reported. Nobody just. I think I can mute that. Thanks. Okay, so these are kind of out of order, but this is down here. Okay, so we now have the first, second, and third quartile. Okay, and this is an easy way to express kind of where some of the data falls. And what we've really found is kind of the cutoff, or the border of the first and second quartile. There's kind of two ways to talk about it, right? We can mention the first quartile and say first quartile is 7, or it's at 7. You can also think about the first quartile as being the chunk of data, so the kind of the lowest 25%, and then the next 25, the next 25, and the highest 25%. Okay. So the quartile is just a fancy word to mean a certain percentile in terms of the calculation. But we can use other words, right? So you'll recognize some of these other words: quintile, septile, decile. We use deciles a lot. Okay, so what is a decile? Deca, decade, decimate. So 10, right? So let's see. Let's calculate something like, we could find the 90th percentile. Sorry, well, where is the cutoff of the 9th decile? Well, it is the same as the 90th percentile. Okay, so anytime you want to do one of these fancier words, to use this calculation, you do have to figure out what the exact percentile is, because we need to plug in 90 into this p. Okay, but we can find the 9th decile, which is going to give us, okay, so L90, so that's 19 plus 1, and then 90 over 100, and that's going to come out as 18, right? 20 times 90 is 1800. And so again, the answer is not 18. We need to go and look for the 18th observation, and here we are. The 90th percentile is 30. So why would we maybe calculate the 90th percentile? What it does is it gives us a cutoff for the top 10%. Right? So the top 10% travel more than 30 miles to work. So this might start to sound more familiar. When do we hear things like top 10% or top 1% or top 5%? Income, wealth distribution stuff. So you'll hear, how much has the top 10% earned this year, or how much value did the top 1% gain since the low point in the financial crisis in March and April. So we use these concepts of the top certain percent of our data quite regularly. Or discussions about, the top 20% versus the bottom 20% and income gains over the last 30 years or something. Those are places where you'll see these calculations quite often. And you can find any of these percentiles with this equation. So, in fact, we don't need a fancy word. We don't need a decile or quartile or quintile to be able to use this. We could find something like, I'm just going to erase some of this. We could find something like the 63rd percentile. Okay, what's the 63rd percentile? It's 19 plus 1. So this would be L63. 19 plus 1 times 63 over 100. That becomes what? 12.6. You can double check my math, but I think that's right. And so this is the 12.6th observation. That obviously is not right on a specific observation. So where is that? Well, let's look at our 12.6. So what do we do when it doesn't fall right on a value? Well, we've already tackled this in the median discussion. Remember if we have an odd number, median's going to fall on a value. If we have an even number, it's going to fall in between, right? So if we had 20 observations, it'd be between 10 and 11. And in that case, we picked the 50th, or right in the middle. We took the average of them. Here, well, in this case, actually, 12 and 13 give us the same value. So it's going to be 14, right? So the answer here is 14. Okay, let's look at one that's not as clean. Let's do the 83rd percentile, or let's do 84th. 84th percentile. Again, we do 19 plus 1 times 84 over 100, which is going to give us 16.8. Okay? We go down to 16, and it's somewhere between 16 and 17, right? Now, if we treated it like median, we would just split it in half. But there's a little more technical way to do this. And I want to just pause and say, what I'm about to do, I'm not going to test you on. Okay? Your book lays this out, and we're going to walk through it because I want you to have seen it, and I want you to kind of wrap your head around it. But we're somewhat because of time constraints, I don't want to get bogged down in this math right here. But also because some of statistics is understanding what could be done and understanding where to find it and that there is a way to do a task. It doesn't have to be just memorizing every equation. So in general, let's back up a second. I want you to understand this equation. I want you to be able to use it and spit out the observations. Go look it up. Say, okay, it's fifth observation, so that it's 7. That's important to be able to do. And I also want you to know that it can be flexible to the point where we can plug in any percentile. I'm less concerned about you being able to do this kind of in between. Outside of, you should understand that there is a way to do it, okay? And so if you ever are, let's fast forward a few years and you're working with data at your job and you know you want the 84th percentile for some random reason, that there is a way to find this specific answer. And so let's just logic our way through it here. So what that means is please read that section in the book, but don't get bogged down by it. What's the logic here? We want to be at the 16th observation and 80% of the way to the 17th observation. Right? 16.8 of the observations. So we want to be in between these two values, but we want to be 80, well, those aren't the values. We want to be in between these two values, the 16 and the 22, but I want to be 80% of the way to the 22, if that makes any sense. So what does that mean? That means there's a distance here, right? One way to think about it is there's a distance of 6. So 22 minus 16 is 6. and I want to have gone 80% of that 6. So 6 times 0.8 is 4.8. Right? 80% of 6 is 4.8. And so to finish out the calculation, we can do 16 plus 4.8. So I'm at 16, and I want to go 80% of the way there, so I add 4.8. And so the actual answer will be 20.8. Okay, that's technically the 84th percentile. Now, as far as your probably studying goes, when I test you on this, as best I can, so obviously I've chosen 19 because this has made most of these calculations pretty clean. And barring me making a mistake, there'll be a similar feel on any question that I ask you, that they should come out to some nice round numbers. But I hope that you know that there is a way to get an exact answer. Okay, so we can do any percentile. Other places you may have seen this. If you have younger siblings or nieces and nephews, or if you have a child yourself, you'll see percentiles a lot, because every time you get them weighed and measured and whatnot, they tell you what percentile the weight is and things like that. We just found my child's head is in the 95th percentile, which no one was shocked to hear. My genetics carried through. And so, so you hear that a lot. You also probably heard it, I assume this is still true when you did standardized testing in grade school. You probably got your reports back and it said you're 73rd percentile in reading and 12th percentile in math or something. Hopefully not, but somebody was 12th percentile. So, okay, so that is the flexibility of the percentile, and So one way to start to visualize some of this data, and not necessarily the percentiles, but we're going to take these quartiles and display them visually in what's called a box plot. So I'm going to get rid of some of this. And so the box plot is, I would say it's been growing in popularity in the last, decade or so in statistics. And one indication of that is that if you have an older version of Excel, it's actually hard to build a box plot. You have to kind of manually do it. And nowadays, so if you're on like Excel 2013, you can't just like make a box plot. But nowadays, it's pretty straightforward, and in fact, you see them quite often in statistics as a way to describe variables. That's because we can put a lot of information into one little picture. And so what we're going to do is we're going to build a box. Okay, and so along this bottom, I'm going to put just the number, or like build an axis here with our numbers, our values for our distance to work. The y-axis is not going to contain any information. Okay, that can change if you have more than one box plot you want to put on one graph, which we can see on we'll see on Friday is actually possible. But in general, there's no information here. It's just going to be kind of along this number line. But what I'm going to do is I'm going to build a box using these quartiles. So our first quartile is at 7. So I'm going to draw a vertical line at 7. I'm going to draw one at 12 and one at 15. Okay, so I have Q1, Q2, which is the median. Okay, and then one at 15, which is Q3. Okay, and you won't always see those labeled, but just for our purposes, I'm labeling. And then I'm going to build the box, right? So here's a box with a line through it at the median, or at the second quartile. And so we're not quite done with it, but here with the box, we have contained all 3 quartiles. Visually, it also tells me So here's the middle 50% of my data, right? 50%, so the median means 50% is less than, 50% is greater than. But within the first and third quartile, there's 50% as well, right? This is 25% is smaller and 25% or greater. So this chunk is 50%, right? And so from 7 to 15 is half of our data. So already I can kind of visually pick up where the data tends to fall. You will hear this, well, this is not used all that often, but what this is the IQR, the interquartile range. Okay, just a fancy way to say Q3 minus Q1. Right? It's the between the quartiles, what's the range? Range in the same context as, right, the overall range here is from 3 to 37, but the range between the quartiles is what? 15 minus 7. So 8. We have an IQR of 8. Now the reason I've calculated that is that we're going to use that to build what are called whiskers. So Excel even goes to the level of calling this a box and whisker plot. You know, kind of more officially or more commonly in statistics, it's just referred to as a box plot, but it contains whiskers. So the whisker length, we're going to build a whisker shooting out in both directions. The whisker length, the default is going to be 1.5 times the IQR. In our case, that's 1.5 times 12, sorry, that's the answer, times 8, which is 12. Okay, so our whiskers are going to be length 12. At least that's where we're going to start. We'll see that one of them won't be. But from 15, I'm going to draw a whisker a length of 12. And I'm going to end it with a vertical line just so it matches these other vertical lines, kind of. Okay, so I have a whisker shooting out that direction. But notice I have a couple data points that don't actually fall within that whisker. When that's the case, I'm going to indicate that by giving them their little star or their asterisk out here. Okay, so there's one at 30 and there's one out here at 37. So when our data falls outside of the whiskers, we indicate it. And what are we really indicating here? These are pretty far away from the rest of our data, or they're extreme, or what we would call outliers. Okay? Because here's half of our data. We have then gone 150% of the distance here, and yet data remains outside of that. So only 25% is larger than this, but some of the data is really far out there. And so we're indicating that there are a couple really large values in our data. And I mentioned this is sometimes referred to as outliers. And in fact, this is one of the ways that we kind of flag values as outliers. There's going to be a couple other ways that we measure that in our course, or one really important way. But this is one way to indicate, again, visually, think about the reader here, picking up a lot of information, but I'm also seeing there's two values that we might want to think more about. What's going on with those? Is there something unique about them? Okay, so all that information's here. I have another whisker to draw. Again, the default length is 12. Okay, so from that, and I'm gonna, so if you're following along and drawing, bear in mind I'm going to change this. But what that would default to is, what is this, 7? So it would stretch to negative 5. Okay, that's not a problem. The whisker can go negative. That's not the issue here. The issue is I don't have data up this way. My data stops at 3. So instead of drawing it all the way to the length, the 1.5 times the IQR, I'm going to do something that you're not supposed to do with whiskers, so don't do this to a real cat, but I'm going to trim my whisker. Okay? They have little nerve endings. It's quite painful, so don't do this. But here we're going to trim our whisker so it only goes to the bottom of our data. If things were reversed and we didn't have any data out this way, we would also trim this whisker. Okay, we can do both of those. So the whisker goes as far as 1.5 times the IQR, is provided that there is data out that far. Okay, so here we have a full box plot. Okay, and again, our goal on this is to quickly tell the story or describe the variable. And by glancing at this, I can pick up a lot of stuff, right? I know the first, second, and third quartiles. I know this is half of my data. I know half is below there, half above. I even know that there's a couple values that are kind of flagged as interesting or outliers. And so just glancing at it, and we'll see actually, it's more and more common to actually build a second or a third or a bunch of box plots all on one graph, especially if you have your data broken up by different kind of subclasses. Excel takes it one step further, so this is not typical in box plots or not kind of the standard way, but Excel will add in a little X, and I don't know exactly where it would be. I don't know if it's in the box or it might be actually outside, to indicate the mean, which I think is useful. But that's not really the standard way, or kind of the traditional box plot doesn't have that X. But you will see that from time to time. Yeah, so can be a really handy way to summarize a variable. All right, so I want to now shift gears a little bit, because everything we've talked about up until now has been about one variable, and how do we describe that variable? How do we summarize what's going on in this one variable? Part of what we touch on in chapter 4 is bringing multiple variables together, right? And so one of the main ones you'll read about in chapter 4 is the scatter plot, right? And this won't be new to any of you, but you can put, income, and this could be distance to work, right? And plotting those out, and it's something that you've done all the way back to graph paper in middle school probably, right? So, but here we have two variables coming together, and how do we describe the relationship between them? And much of what we do, especially later on in the semester, is multiple variables, mixing them, figuring out is there some connection. Eventually we'll talk about, is there correlation, and can we describe that as causation between these variables. So we will spend a lot of time with multiple variables at a time. And so how do we try to summarize the relationship, or just multiple variables at one time? And so a big tool for that is going to be what are called contingency tables, or in Excel you'll see them as pivot tables. And really what they are is two frequency tables smushed together. Okay, so frequency tables being where, remember, we break it up by kind of class, or we can also build these with quantitative variables, so frequency tables or frequency distributions, smushing them together, right? So in that case, we'd have to build our bins. So what I want to imagine, I don't know if I'll write out all this data, but maybe I have data from all of these people as well. And I know, favorite team, and I know this is Packers, Vikings, Bears, okay, and this is P, V, Bears, okay, and on down, right? So we've seen this before. We've seen a variable like this. I also want us to think we know, okay, so favorite animal. Okay, and this is cat, dog, and so on. Okay, silly example, but we have two variables, and we want to summarize them together and start thinking about, is there a connection there, or how do these play together? So I said they're like a frequency table, or two frequency tables pushed together. And a contingency table has in it the full frequency table. So, for instance, Packers, Vikings, Bears. Okay, what does a frequency table do? We would count up the frequency and say, okay, here's 1, 2, 3, 4, 5, 6, 7. Maybe 8 of them came out as Packer fans. Right? I'm leaving a little space that we'll fill in later. But we had 8 Packer fans. We had 7 Vikings fans, and we ended up with 4 Bear fans. Okay? And so there we have, this is team, and this is the frequency, and there's our frequency table, right? We just counted up, and in Excel we could even do like the count if statement. But now we have a second variable we want to play around with. So we have animal, we have dog, and cat. Okay, again, I know this is kind of a silly example, but how many, so forget about these for now, how many chose dog? And maybe we had 12, and 7 chose cats. Okay, so again, so in a typical frequency table, right, we have a little total down here. So 8 plus 7 plus 4 is 19. It's also going to be the total this way, right? 12 plus 7 is 19. So assuming everybody answered both questions, they would be included in this table. And we have, so this kind of total down here works for the columns and for the rows. Okay, so there's the 2 frequency tables. But we have a chance to get more information. What about connecting these two? So we have 6 cells here, not filled in. What's true in this cell? That person listed Packers and dog. Okay, so all of these cells are and statements. Both of these things are true. Packer and dog. Okay, so in the blue over here, that's a Vikings and a cat. So how many Packers liked a dog? Maybe it came out that there were 5. Okay? If that's the case, it better be true, and here's one of them, Packer and a cat. Okay, so that's definitely one here. We probably should find 2 more down here that did Packers and cat, right? Because this total Packers includes the Packer fans that like dogs and the Packer fans that like cats. So this 8 is 5 plus 3. Right? Again, everybody's filled out these questions, so if you chose Packers, there's 8 of you, 5 of you chose dogs, then the other 3 must have done Packers and cats. Okay, similarly, let's say this was 6 and 1, and for Bear fans there was then 1 and 3. Okay, I'm just kind of making this up, but you could imagine the data here. We're counting them all up. Again, they're going to sum across 6 plus 1 and 1 plus 3. They're also going to sum down, right? Because I have 12 people that chose dog. 5 were Packers, 6 were Vikings, and 1 was a Bear fan. Totals 12. This column totals 7. Okay, so can be useful information, right? Because we can start to describe how these flow together. Again, this is kind of silly, but you could imagine, again, more things, more important, incomes and life satisfaction and what college major you chose. That might be interesting to some of you. So we could start looking at that data in a form like this. But you can see where this can start to at least have you starting to ask questions. Again, what we're doing here is not, there's no statistical testing going on yet. We haven't gotten to where we can make definitive statements. But sometimes when you start to describe the data like this, it at least raises the question in your mind and leads you down different roads, right? So what do we kind of look at this and say, well, dogs were, more people like dogs than cats, and that was very true for Vikings. It was true for Packers, but why did the Bears fans tend to like the cats? Is there something going on, right? Are they're both furry, fuzzy animals, more so than dogs maybe. Maybe you're really into claws. But you could start to at least try to think about, well, how would I test this? How would I examine this question more deeply? Again, a silly example, but this is kind of when you start to describe the variables and start to put them together, you can say, all right, is there a relationship here that I should look more closely at? Again, that's a lot what a scatter plot is, right? You've seen these before, and you say, okay, it's kind of messy, but there seems to be some relationship where as the x variable gets bigger, the y variable goes down, or something like that, right? That's a lot what we use scatter plots for. A similar idea. We just want to see the data either fully visually or more summarized than just staring at this wall of data. So yeah, pivot tables. So this is a contingency table or a pivot table, as Excel calls it. They are used quite frequently in business. Most of the MBA students that come in are quite familiar with drawing pivot tables in Excel and do that quite often. So somewhere down the road, it's not crazy to think that you'll be clicking and dragging in Excel. And we'll see that on Friday. So if you can be there on Zoom or watch it, it'll be posted later. We'll see how to do this in Excel, and your problem set 2 has you do it a couple times with some Titanic data. Yeah, and just like with the what was I going to say? With the frequency table, we went and kind of learned it, equals count if, and we learned how to do it with the formulas. But there were we could also have the Excel or the data analysis tool pack help us. There's even a more straightforward. You can insert a pivot table really quickly, and with 5 clicks of the mouse, you can have this pop up on your screen. But it does take a little practice to figure out how to drag stuff around and have it count instead of taking the average and stuff. So we'll walk through that on Friday, and then you'll have some practice by this weekend on it. Yeah, we got through the big 3, or at least the ones that I think will be helpful for you to have seen. But yeah, take a look, and remember again, that Connect assignment is due Friday. So if you haven't started to dig into the chapter and watch some videos, please do so. And then, problem set on Sunday. So I'll stick around for a few minutes if people have questions. Otherwise, and then, office hours, I'll be around later today too and on Friday.